Now we're going to take a look at the concept of adding and subtracting vectors. So we'll work on an example. So suppose this is the shore, and there's water here. And there's a swimmer, okay? Actually, let's start with the water. There's a current, okay, going in this direction, okay, of 2 kilometers per hour. And then you've got a swimmer, okay, that decides to swim at 3 kilometers per hour. Okay, pretty fast, but that's actually manageable. He's heading with an angle of 45 degrees. Okay, so 3 kilometers per hour. So 3 kilometers per hour is the magnitude, okay, of his velocity, and then there's the current also that has a magnitude and a direction. What we'd like to know is how fast the swimmer is swimming with respect to the shore. So if someone standing like by the shore looks at the swimmer, what is the impression for that person? Okay, so how fast does the swimmer swim, and in which direction? In which direction with respect to the shore? Because someone taking a look at that swimmer, okay, will have the impression that he's swimming a lot faster than 3 kilometers per hour because he's being helped by the current. So the effect is that the swimmer swims like this, but the current takes the swimmer also in this direction. So there's sort of what we call the addition of 2 vectors going on here. Okay, so the resulting magnitude and direction of the swimmer will be indicated with a vector like this. So with respect to shore, this is the impression we're going to have for that swimmer. Okay, so first of all, we can see that the angle, okay, will be a bit smaller than 45 degrees because the swimmer is being carried away to his right by the current, and the effective speed of the swimmer is larger than 3 or 2, okay, because it will correspond to the length of that vector, which is clearly larger than 3 and 2. So this is what we're looking for here. So to start this problem, we will first find the position vectors, okay. So we've got this first vector of length 3 with an angle of 45 degrees. So what's the position vector here? In other words, if the vector would be placed so that it starts at the origin, what would be its coordinates? Well, we saw in an earlier video, this is 3 cos of 45 degrees and 3 sine of 45 degrees. So this is approximately, well, we know what exactly this is equal to. This is 3 root 2 over 2, 3 root 2 over 2, and approximately this is 2.12 and 2.12. For the other vector, it's much easier because the current's just like that. So obviously, if it starts at 0, 0, we go forward by 2, and we don't go up at all. So it's just 2, 0. So now what we want to do is add up those 2 vectors. So we've got this vector with coordinates 2.12, 2.12, and then we need to add this other vector. And notice that how we add vectors, we place the tail of the second vector where the head of the first vector is, and this other vector is 2, 0. Okay, actually I gave, we can call this vector here S for swimmer, and this one W for water. Okay, so this is vector S here, this is vector W. And then we need to add those two. So how do we add using the coordinates? This is the whole purpose of the first part of this video. Well, notice that if this is the x-axis here, so we need to see how he's moving forward. Well, according to the S vector, this is going forward by 2.12. Now, according to the W vector, this is moving forward by 2. So it seems that to get the coordinates of vector, let's call it V, the resulting vector, okay, we need to add the coordinates. Okay, so so vector addition ends up by adding at least the x coordinates, and it's not too hard to see that we can do just the same with the y coordinates. Because how much do we go up? Well, we go up by 2.12 because of S and by 0 because of W. So so again, along the y-axis, we also add up the coordinates. Okay, and then we get 4.12 and 2.12, like that. So so we see that S plus W, which is our vector V, is obtained essentially once we find the coordinates. So I can draw a diagram, but actually once I have those coordinates, all I need to do is add up the coordinates. It's as simple as that. Okay, and with this I can answer the question. I can find with the coordinates the magnitude and the angle, because this is something we've done in the previous video. So vector V, if it's positioned so that it starts at the origin, the coordinates of the head are 4.12 and 2.12. And then we can come up with the magnitude and the angle. Now the angle, we see it's going to be acute, so we're going to be able to find the angle by taking the arctan of the ratio of the y value over the x value. Okay, so this is basically doing the arctan of the opposite side over the adjacent side, and we get here an angle of 27.23 degrees, and so it makes sense because we were anticipating an angle that's less than 45. Remember, so the swimmer is swimming at an angle of 45, so this angle theta should be less than 45. We see it on the diagram, so this makes a lot of sense. And now the magnitude of V is the square root of the sum of the squares of the coordinates. And this is going to give us approximately 8.61. So this is kilometers per hour. So finally, with respect to the shore, the swimmer swims at a speed of 8.61 kilometers per hour with an angle of 27.23 degrees. Okay, so once you solve a problem like this, always try to write down in a sentence or summarize somehow your findings, okay, to answer the question. So in general, right, if we've got a vector A with coordinates, so if A is equal to a vector with coordinates x1, y1, and B is a vector with coordinates x1, y1, x2, y2, then adding the vectors A and B is simply done by adding the coordinates. Okay. Geometrically, what does that correspond to? If this is vector A, And let's place vector B so that it starts also at the origin. So this is vector B. If I do A plus B, so actually I'm going to draw B in red. A plus B would be obtained by placing B so that it starts where A ends, okay? And the resulting sum would be essentially this vector here. Okay, now if you look at this vector here, this is also vector A, right? Just move A around. So what we have here is a parallelogram, right? So formed by the vectors A and B. So A plus B is actually a diagonal of this parallelogram. And we also see just from the diagram that A plus B is the same as B plus A. Okay, so note number 1, A plus B from this diagram, we can clearly see it, is equal to B plus A. So addition of vectors is can be, the order doesn't matter, right? So we say it's commutative. And A plus B is a diagonal of the parallelogram. Let me spell that correctly. Determined by vectors A and B. So I say a diagonal because there's another one. There's also, I didn't draw it, but let me add it right now. There's also this diagonal I haven't talked about. So we're going to talk about it very soon. Now, let's try to answer another question with respect to the swimmer. So what if the current is in the other direction? Okay, so again, you've got the shore, you've got water here, but this time the current goes like this at 2 kilometers per hour. And our swimmer is still going at 3 kilometers per hour with an angle of 45. And now I want to find like what's the resulting vector now, and possibly the angle. Well, notice that to get the resulting vector, all we're going to do is, so this is again vector, let's say S here for the swimmer, and W for water. Okay, well, not equal, this is just W. So to get the resulting vector in this case, okay, what are we going to do? We're going to take S, and we're going to add this vector here. So actually, this vector is not exactly W, it's the opposite of vector W. So we're going to put the little negatives here, okay, because it's in the opposite direction. Okay, so W will be vector S, to which we add the opposite of W. So we're going to write this as S minus W. And it's not too hard to see that to get the coordinates of V, we're going to take the coordinates of S. Well, now we're going to subtract the coordinates of W, and then we're going to get 0.12, 2.12. Okay, in this case. And then from this we could recover the angle and the magnitude, okay, of the speed at which the swimmer is swimming with respect to shore. So maybe a definition here. So if A is x1, y1, and B is x2, y2, then A minus B is simply, again, obtained by subtracting the coordinates. Okay, geometrically, what does that correspond to? So let's draw vector. I want to look at my diagram again. Okay, I'm going to redraw this. A, B. Okay, let's say A like that, and B like that. Okay, so we've seen that if I create this parallelogram, okay, so actually maybe let's draw B in red again. This is vector B. So this is vector B again here. If I and vector A. Okay, if I add the arrow like that. Okay, and we saw that the arrow going from there to there, that's A plus B. So I've basically just redrawn this in the diagram we had before. Now if I do A minus B, okay, that's the same as, so maybe I can add this as a note. A minus B is the same as adding to A the opposite of vector B. Now what's the opposite of vector B? It's this vector here. Let me add it in, maybe in orange. Yeah, that's a good idea. So the opposite of vector B is here. This is the opposite of B. Okay, so if I take A and add the opposite of B, I do A, so I go along A, like this here, go along A, and then I'm going to place the opposite of vector B so that it starts where A ends, and let me again add vector A here. We're going to create a new parallelogram, okay, which is actually, it's a new parallelogram. It looks a lot like the one we have before. It's just oriented, just shifted a little bit, and A plus minus B. Now minus B is here, right? This is the vector minus B again here. So A minus B will result in, let me add it in yellow maybe. A minus B will result in this vector. But it's actually this vector here. So A minus B ends up being the other diagonal of this parallelogram. Okay? So A plus B is one diagonal, A minus B is the other one. And A minus B starts at the head of B and ends at the head of A. So you have here in a nutshell, geometrically, what A plus B and A minus B corresponds to when we have two vectors.